Hello students, welcome back to our channel Diksha Karnataka. So in today's video, I'll be discussing top 30 questions from the chapter Structure of Atom. Right, so this is a low weightage topic. You can expect 1 to 2 questions from this chapter, but I'll be covering all the important topics from where questions can be asked. Okay, so now let us see the first question. The number of protons, neutrons and electrons in this S16, 32, 2 minus respectively are. So this is very simple question. Just I'll explain what is. Suppose you have any element X. Here the number which is represented is called as your atomic number. Okay, that is represented by symbol Z, and this one is your mass number. Right. So now Z denotes the number of protons and A denotes the number of protons plus number of neutrons, right? So now in this question, if we see S16, 32, 2 minus, right? So this 16 is the number of protons. Here you have to be careful the order in which they have asked. So they have asked you protons, neutrons and electrons, right? So 16 is the number of protons. Now this is the total number of neutrons plus protons. So if neutrons plus protons is 32 and proton itself is 16, then neutrons will also be 16. Then electrons, you can see generally what happens in a neutral atom, the number of electrons and number of protons are similar. So it should be same. So 16 electrons should be there. But here we can find 2 minus charges there. So an additional 2 electrons are there. So 16, 16 and 18. So correct answer for this question will be option number B. Okay, now let us see the next question. If the wavelength of a photon is 2.2 into 10 to the power of minus 11 meter, H value is 6.6 into 10 to the power minus 34 joule second, then the momentum of the photon is. So this question is from your de Broglie wavelength, lambda is equal to H by P. We need to calculate momentum, so that is equal to H by lambda. H is equal to 6.63 into 10 to the power of minus 34 joule second divided by momentum we have to calculate, and lambda given to you is 2.2 into 10 to the power of minus 11, right? So now just for easy calculation, you can take it as 6.6, this one as 2.2, so we'll get 3 into 10 to the power of minus 23. Okay, so correct answer for this question will be option number C. Simple calculation. Next question. The number of angular and radial nodes in 3p orbital respectively are. So if we have the formula for radial nodes is, radial node formula is n minus l minus 1 and angular node formula is l, okay, and the total number of nodes formula is n minus 1. So now we have seen what is the orbital given 3p. So here what is n value? N value is 3, l value is p, right? So we have s, p, d and f. So s stands for 0, p1, d2 and f3, right? So p will be 1. So now if we calculate 3 minus 1, so that will be 1. So number of radial nodes is 1. Okay, and then we have angular nodes. Angular nodes is L, so that is also 1. So angular nodes is also 1 and the total number of nodes will be 2. So the correct answer for this question is option number B. Okay, next. With regard to photoelectric effect, identify the correct statement among the following. This photoelectric effect, numericals, more than numerical statement based questions are important. So just see here. Number of electrons ejected increases with the increase in the frequency of incident light. This statement is wrong. Please remember, if frequency increases, then kinetic energy of the electrons will increase. Second statement, number of electrons ejected increases with the increase in work function. So this is incorrect. That is no relation between that. Now number of electrons ejected increases with the increase in the intensity of incident light. So if the intensity will increase, then number of electrons ejected will also increase. This statement is correct. Next, energy of the electrons ejected increases with the increase in intensity light. This is also wrong. Energy will increase if frequency will increase. So the correct answer for this question is option number C. So there are two things you have to remember. Energy of the ejected electrons depends on the frequency and the number of ejected electrons depends on the intensity. Okay. Next question. Two particles A and B are in motion if the wavelength associated with A is 33.33 nanometer. So wavelength of A is 33.33 nanometer. The wavelength associated with B, whose momentum is 1/3 of A. Okay, so let the momentum of A is P. we have to calculate the wavelength of B, and the momentum of this one is 1 by 3 of P, right? So we have this formula, lambda is equal to h by P. So I write here, that means lambda is proportional to 1 by P. So we can write lambda 1 by lambda 2 is equal to P2 by P1. Now let us write lambda 1 is 33.33. Okay, lambda 2 we have to calculate. P2 value is 1 by 3P, and P1 let it be P. So what I'll get, lambda 2 will be equal to 9. So you can multiply here, 99.99. The units you can see it is in nanometer. Okay, the options are in meters, so we can write this one as 99.99 into 10 to the power of minus 9 meter, which can be further written as 0.9 into 10 to the power of minus 7, or it is equal to 1.1 into 10 to the power of minus 7. So correct answer for this question is option number D. Okay, next, the orbital nearest to the nucleus. So we know s orbitals are very close, so 4s will be the correct answer, option number C. Next, the correct set of quantum numbers for the unpaired electron of chlorine atom is. So if you remember, fluorine, chlorine. So here chlorine electronic configuration is 3s2 3p5. So if I do 3p5, we have 3 orbitals here. So this is 3s and this is 3p. We have 2 electrons here and we have 5 electrons here, right? So the question is asked about this last electron. So now we can see n value, we can easily see it is 3. So we can eliminate these options. Okay. Now L value is P, right? So we can also eliminate this option. So correct answer will be option number D. But let us check the other quantum numbers also. Here it is -1, 0 and +1. So ML values is also +1, and the spin quantum number can be ±1 by 2. So the correct answer for this question is option number D. Next, the energy of the electron in the nth orbit of, so this is very famous formula, En is equal to -13.6 z square by n square. Okay, so correct answer for this question is option number A. Next, consider the following set of quantum numbers. Which of the following is not permissible arrangement of electrons in an atom? So which one is not possible? So before that we will discuss all the quantum numbers and their ranges. Okay, so for principal quantum number, it can be any value from 0 to infinity. Okay, sorry 1 to infinity. Okay, so it can be any value that is from 1 to infinity. Next we have the quantum number that is azimuthal quantum number. It ranges from 0 to n minus 1. Then ml stands from -L to +L, and ms stands from ±12. Okay, these are the quantum numbers possible. So now you see, if n value is 4, right? So what are the possible values of L? 0, 1, 2, 3. So that is correct. Okay. Now ml values can be from, for L value 0, this one will be 0. And here it can be +1 by 2 or -1 by 2. So this arrangement is possible. Now if n value is 5, the possible L values are 0, 1, 2, 3 and 4. So 3 comes there. So this is also correct. Now m value for 3 will be -L to +L. So 0 comes there. So this is also correct. Spin value can be plus or minus 1 by 2. That is also correct. Now if you see 3, for them the L value is 0, 1 and 2. So here it is taken 2. This is correct. ML value for L is equal to 2 will be -2 to +2. So this is also correct. This value is also correct. Now let us see this one. So the correct answer should be D. N is 3. Okay. So L values can be 0, 1, 2. This is correct. But ML value for this one is -2 to +2. Right. -3 will not come. So this part is given wrong. Okay. So the correct answer for this question is option number D. I hope this is clear. Quantum number is very, very important. So please prepare properly. Okay. The 2 electrons have the following sets of quantum numbers. Which of the following statement is true? Okay. So it is about energy, right? So how to calculate energy of any cell? To identify the order, it is N plus L rule. Okay. What does this rule say? You have to calculate N plus L value. The one whose N plus L value is greater, okay, its energy will be more. Okay. Now suppose the N plus L value comes same. For example, you take 4s orbital, okay, and we can have 3p orbital, right? So here what is N value? 4 and L value is 0. So 4 plus 0 is 4. and here n value is 3 and p value is 1, so this is also 4. So in such case, if n plus l value comes equal, then the orbital whose n value is higher will be having higher energy. So here n value is higher, so this 4s will have higher energy than 3p, right? Like that we can calculate. So this was the theory part. Let us see the question here. What is the n plus l value for this one? 3 plus 2, 5. For p it is n plus l value is 5, and here it is 3 plus 0. So for q it is 3. So obviously p will have greater energy. P has greater energy than q. Correct answer is option number A. Okay, easy question. Among the following elements from atomic number 1 to 36, the number of elements which have an unpaired electrons in their s subshell. So this is nothing, there's no formula, nothing involved. You have to just see the electronic configuration and find out the answer. So we have first of all hydrogen, right? It has an unpaired electrons. Then helium is not there, lithium, all the group 1 element, sodium and potassium, right? After this you also have a barrier up to 36, right? So we can check the 20 to 21, that is, sorry, 20 to 30 D block elements. In that we have chromium and we have copper, right? This is 3d5 4s1 and this is 3d10 and 4s1. So we have unpaired electrons in s orbital. So total we'll get 6. So correct answer for this question will be option number C. Okay, next question. The statement that is not correct is, so angular momentum signifies the shape of the orbital. Energy, so this is correct. Energy of the stationary states in hydrogen like atom is inversely proportional to the square of the principal quantum number. This is also correct. We have this formula, En is equal to minus 13.6 z square by n square. So inversely proportional to square of the principal quantum number. Then total number of nodes for 3s orbital is 3. This one is incorrect because just now I told you what is the formula for total number of nodes. Total number of nodes is n minus 1. So for 3s the total number of nodes will be 2, but they have given you 3. So this is incorrect statement. Correct answer for this question will be option number C. Okay, next. The de Broglie wavelength of a particle with mass 1 gram and velocity 100 meter per second. So de Broglie wavelength formula, lambda is equal to h by, we have to calculate h by p, or that one can be written as h by mv. Okay, so now let us solve this. We have to calculate h value is 6.6 into 10 to the power of minus 34. Then mass of the given is 1 gram. So mass should be in kg. Okay, so that means 10 to the power of 3 kg. And then velocity is given to you 10 to the power of 2 meter per second. So if I solve this, we'll get 6.6 into 10 to the power of minus 34 by 10 to the power of minus 1. So we'll get 6.63 into 10 to the power of minus 33. So the correct answer for this question is option number C. Okay, next, calculate the wavelength associated with a proton moving with this much speed, mass of the proton. Again, this is called as your wave nature of particles. Okay, so what is the, again we can calculate wavelength. Lambda is equal to h 6.6 into 10 to the power of minus 34 divided by mass is already given in kg, 1.67 into 10 to the power of minus 27 kg, into velocity is 10 to the power of 3, right? So now if we solve this, we'll get 6.6 into 10 to the power of minus 34 divided by 1.67 into 10 to the power of minus 24. So that will be 6.6 by 1.6 into 10 to the power of minus 10, right? Now you see the question is asked in nanometer. So this one was coming in meter. We'll multiply into 9 to get meter. So it will be 6.6 by 1.6 into 10 to the power of minus 1. Right, so this one is somewhere around 16 4s I 64, so something around 4 we will get. 4 into 10 to the power of minus 1, that is 0.4. So the correct answer for this question will be option number B. Little calculation based but easy calculation. Okay, this is important question. N plus L rule we have to apply. 4 different sets of quantum numbers are given below, E1, E2, E3 and E4. The order of their energies are. So for everyone we have to calculate the n plus L value. Let us quickly do that. For E1, n value is 4, L value is 0. So 4 plus 0 is 4. For E2, that is 3 plus 1. So that is equal to 4. For E3, okay, so E3 is 3 plus 2. So that is equal to 5. For E4, it is 3 plus 0. So it is 3, right? So if you can see here, the highest energy should be for E3 and the lowest energy should be for E4. So we can see there is only one option with E3 highest energy and E4 lowest energy. So that is why these all answers are incorrect. Correct answer is option number C. Now if you want to discuss between E1 and E2, for E1 the n value is 4 and here the n value is 3, right? So that is why E1, I told you when n plus L values comes to be same, we have to consider n value. Okay, the n value which is having higher, that energy will be higher. So now if you see here, this is n value is 4, that is higher, so E1 will be higher. So E3, E1, E2 and then E4. Correct answer is option number C. Okay, next. The maximum number of electrons in the shell with the principal quantum number n is. So this is direct formula based question. We have 2n square. Okay, correct answer is option number A. Next, the magnetic quantum number represents. So magnetic quantum number represents the spatial orientation of the orbital. So correct answer for this question is option number D. So if you have remembered, n is represents the energy of the shell. Okay, L represents the shape of the orbital. ML represents the spatial arrangement of the orbital. Okay, so you can just remember quantum numbers. Many questions are asked based on their significance, based on the like how many electrons are there in this orbital, that orbital. So such questions are asked. Okay, now this comes to your electron filling rules. So Hund's rule. What does Hund's rule say? In orbitals of equivalent energy, electrons spin remain unpaired if possible. Yes, this statement is correct. Yes or no? We have our Hund's principle. Okay, next we have Pauli's exclusion principle. No two electrons can have all the 4 quantum numbers identical. This is also correct. Now Zeeman effect is the magnetic effect on the atomic spectra which divides the atomic spectra. Uncertainty principle, it is impossible to determine the position of the electron. This statement is incorrect. It is impossible to determine the position of an electron simultaneously. Okay, simultaneously with the position, with the momentum of the electron. With the momentum of electron. That means we cannot calculate the momentum and position simultaneously accurately. If we are calculating position correctly, momentum will be wrong. If you want to calculate momentum correctly, there will be some error in the position. Okay, that is the statement. So correct answer for this question is option number D. Okay, next, number of angular nodes for 4D orbital. So angular nodes formula I have already discussed. Angular nodes formula is L. In 4D, this is 0, 1, 2 SPD. So that is number 2. Okay, option number C. Next, which of the following values of angular momentum is not permitted? So this is very important question. Angular momentum, okay, denoted capital is n times of h by 2 pi. Okay, it should be an integral multiple of h by 2 pi. So here this is an integral multiple, 1 into h into 2 pi. This is 3 into h by 2 pi. This one we can write like it could have been like this, 4 into h by 2 pi. Then this got cancelled and it become 2 into h by 2 pi, h by pi, right? So this is also a correct one. This 3, okay, we can write this one as 3 by 2 into h by 2 pi. 3 by 2 is not a whole number, it is 1.5, it is a fractional number. So this is incorrect. Correct answer for this question will be option number D. Okay, now let's see the next question. The frequency of radiation of wavelength 6000 angstrom is. So this is very simple question. We have C is equal to lambda into frequency. So if you want to calculate frequency, it is C by lambda. C is 3 into 10 to the power of 8 meter per second. Then lambda is 6000 into 10 to the power of minus 10 meter. So we will get here 1 by 2. Sorry, we can just calculate this one like this. So we have 3 into 10 to the power of 8 by 6 into 10 to the power of minus 7. So we can get here 0.5 into 10 to the power of 15, or I can write it as 5 into 10 to the power of 14. Right? So the correct answer for this question is option number C. Next, according to Aufbau principle, which orbital is filled immediately before each of these orbitals? Okay. So according to Aufbau principle, the rule says that the electron should be filled in the order of the energy of the orbitals. Means the lower energy orbital should be filled first and the higher energy orbital should be filled later. So what is the question is, before 4s which orbital must have been filled? Okay, so if you have remembered, before 4s we have 1s, then 2s, 2p, 3s, 3p, then we fill up 4s and then 3d is filled up, right? So before 4s 3d should be filled, sorry, before 4s 3p should be filled. So we can eliminate this option, these all are having 3p. Let us see the next one. Now if we know before 3d, so what is the order? First 1s, then 2s, then 2p, then 3s, then 3p, then 4s, and then 3d, right? So what I can say, before 4s 3p has to be filled. Similarly, before 3d 4s should be filled. So that so we can eliminate this one also, because before 3d we have 4s. Okay, now you have to check with these two, 4d and 4f. So now if you see before 4f, what is the energy of this one? 4 plus spdf, 0 1 2 3. So 4f is 7. Now if you check here, 6s can also be filled, and 4, so what is the energy for 4d? 4d is, that is your 6, and 6s is 6, right? So both are coming together, so we cannot differentiate here. Then let us check the next one. Before 5p 4d has to be filled, right? So the correct answer here for this question is option number B. Okay, what you have to do is you have to learn this order. What is the filling of order of electrons here? So if you have seen that order, it will come after 3d. Before 4f 6s should be filled, before 5p 4d should be filled. Okay, next question. Mark the incorrect statement regarding the photoelectric effect. Okay, very important again. There is no time lag between the striking of light beam and the ejection of electrons from the metal surface. This is correct. This could be explained using the particle nature of light. The number of electrons ejected is inversely proportional to the intensity of light. So this is also, just now I told you, if we want to calculate energy of the ejected electrons is directly proportional to frequency, number of ejected electrons is directly proportional to intensity, right? So this statement is incorrect. Next, photoelectric effect is not absorbed below threshold frequency. Yes, this is also correct. Next we have, the kinetic energy of the electron increases with the increase in the frequency of the light. So the incorrect statement from the given 4 is option number B. Okay, now coming to the next question. The third line of the Balmer series in the emission spectrum of hydrogen atom is due to the transition from the third line in the Balmer series. So for Lyman-Balmer, n is equal to 2. Okay, in Balmer series n is equal to 2. First line will come when the transition is from n is equal to 3. Second line will come when the transition is from n is equal to 4. And the third line will come when the transition is equal to n is equal to 5. So we will get the third line from 5th Bohr orbit to the 2nd Bohr orbit. Okay, correct answer for this question is option number B. Okay, next. The energy difference between the ground state of an atom and its excited state is 3 into 10 to the power of minus 19. What is the wavelength of the photon required for this transition? Okay, so now if you see, we have this formula, E is equal to hc by lambda. We have to calculate the wavelength, right? So I can use this one here. Okay, so E given is 3 into 10 to the power of minus 19 joules. H value is 6.6 into 10 to the power of minus 34. Then this one is 3 into 10 to the power of 8. Then we have lambda, right? Now we can calculate lambda value will be 6.6 into 10 to the power of minus 34 into 3 into 10 to the power of 8 whole divided by 3 into 10 to the power of minus 19. Okay, so now I can cancel this part. Then we will get 6.6 into 10 to the power of minus 34 plus 8 and then plus 19. So if we solve this, we'll get 6.6 into 10 to the power of minus 7. Okay, so correct answer for this question is option number D. Okay, next question. A 100-watt bulb emits monochromatic light of wavelength 400 nanometer. Calculate the number of photons emitted per second by this bulb, right? So we have this formula, E is equal to N H nu. Okay, So here lambda is there, so I can write NHC by lambda. We have to calculate this n value. So n value will be equal to E H into C into lambda, right? So just arrangement of equation. Now you can substitute all the values here. Energy given is 100 watt. Then lambda value is 400 nanometer. I can write it in meter. Then this one is 6.6 into 10 to the power of minus 34. C is 3 into 10 to the power of 8. So now you can just do the calculation here, little lengthy calculation. So the answer coming here will be around 2 into 10 to the power of 20. Okay. So options are very near. So little carefully you can do the calculation. So correct answer for this question is option number C. Check this calculation. If you do not get the answer, you can comment it. I'll solve it in detail. Next, the energy of a hydrogen atom in the ground state is minus 13.6 eV. The energy of the level corresponding to quantum number 5 is. So E of any orbital is minus 13.6 z square by n square. Here since it is hydrogen atom, it's given hydrogen atom, right? Yes, hydrogen atom. So n z value is 1. N value is quantum number 5. So minus 13.6 by 5 square. So this value will be giving to you around minus 0.54. Okay. So the correct answer for this question will be option number A. Okay. Simple one. Next, the wave function of an electron of an atom depends on. So the wave function that we generate from the Schrodinger equation depends on the position of the electron, and position of the electrons is given by the coordinates of the electron. So the correct answer for this question is option number D. Next, the wavelength of the first line of the Lyman series is lambda. The wavelength of the second line of the Lyman series is. Okay, this question is little tricky and easy one also. See, for Lyman series, the first line will come when n is equal to 2 to n is equal to 1. This is the first line, and the question is asked for second line, that is n is equal to 3 to n is equal to 1. Right? Now we can do this formula. We know 1 by lambda 1, okay, is equal to RH by 1 by 1 square minus 1 by 2 square. So I will get this one, 1 by lambda 1 is equal to RH into 4 minus 1, that is 3 by 4. This is one equation we'll get. Another we have 1 by lambda 2 is equal to RH into 1 by 1 square minus 1 by 3 square. Okay. So if we solve this one, we will get 1 by lambda 2 is equal to RH. Then we will have 9 minus 1, that is 8 by 9. Now just take the ratio of both these equations. We will get 1 by lambda 1 whole divided by 1 by lambda 2 will be equal to RH, we can be cancelled, 3 by 4 and then divided by 8 by 9. So that is equal to 3 by 4 into 9 by 8, that is 27 by 32. Here this is equal to lambda 2 by lambda 1. So lambda 2 is equal to 27 by 32 into lambda. Okay. So 27 by 32 into lambda is option number A. Okay. So correct answer for this question is option number A. Please see the solution once again. Any doubt in this question also you can comment. Very easy question this one. Okay. Now let us see the next question. The frequency of the photon emitted during a transition from n is equal to 5 to n is equal to 2 state in the hydrogen atom is. So frequency is asked, but this is little indirect question. We know the energy formula. The energy difference is minus 2.18 into 10 to the power of minus 18, 1 by n1 square minus 1 by n2 square. So the transformation has taken from n is equal to 2 to n is equal to 5. So we can write like this, minus 2.18 into 10 to the power of minus 18, 1 by n1 square is 2 square minus 1 by 5 square. So if we solve this one, we will get 4.5 into 10 to the power of minus 19. Okay, just solve this one and check once. Now the question is to calculate the frequency. So frequency we can write E is equal to h nu, right? So I can write frequency will be equal to E by h. So E value is given to us, this one 4.5 into 10 to the power of minus 19, and this one is 6.6 into 10 to the power of minus 34. Okay. So now if you solve this value, the answer will be getting should be somewhere around 6.9 into 10 to the power of 40. Okay. So the correct answer for this question is option number C. So you can see this part, right? This part is correct for all. We just have to take care of the power part. So it is 19 plus 34. Okay. So check the calculation once again. If any doubt here, you can let me know. So that were the top 30 questions from the chapter structure of atom. It is a very low weightage topic. You can get hardly 1 or 2 questions from this chapter. If you have completed all the high weightage chapters, then go for this chapter. In this also, you can focus on the quantum numbers majorly, and then on the hydrogen Bohr's model, and then uncertainty principle and de Broglie wavelength. Okay. If you have found this video helpful, please like, share and subscribe the channel. The link of the WhatsApp channel will be there in the description section. You can join that for your further updates. Thank you.